Hi, everyone. We're going to talk about EPANET. This is a modeling software that the EPA has created to simulate flow and water quality and pressure in pipe networks. So here's the website, and I've got it linked on the assignment, so you can find it there. We're going to scroll down, and we can have some different options here. Note that this runs on Windows or PC. Will not run on Mac as far as I know, unless you have an emulator. Good news is if you have a PC, you can install it with these two options here. We'd use this one, the 2.2 version. If you don't, you can go to a lab computer, download this, put it in a folder, and it doesn't need to install. It'll just run on a lab computer. All right, so we're going to assume you've done that. You've gone ahead and downloaded, and you've opened it. So here it is. Now, if you are not a child of the 90s, you might not recognize these kinds of windows, but this is really old school graphical user interface here. All right, so I just opened this up. And I'm going to look at a few things here. I got to hide my um, meeting control so I can see everything. So we just do file new, create a new thing. You've got a blank slate here. I'm going to run through some of the just default settings and change things so it's just kind of easier to use. So first thing we're going to look at here is, let's see here, defaults. So project defaults. Label IDs we're not going to worry about, but let's go to properties and just note that by default, whenever you create a node, which is a junction, a tank, or a pipe, these are the default values that are going to go into that. Now, we don't really care that much. You can always change them, but just note that that's what they're going to start off as. Under the hydraulics tab, this is where you can choose your units. And for flow units, it's defaulted to gallons per minute. For our lab, we're going to use cubic feet per second. So let's do that. Head loss formula, we got to go old school. Let's do Darcy-Weisbach. And then the rest, we're going to leave this the same here. This is really just how does the model solve and when does it stop iterating in terms of accuracy for different things that it's calculating. Okay, press OK. Now we're going to go to View and Options. And there's a lot of different things we can change here. I like a black background, just a little easier on my eyes. Flow arrows, these are nice to show you the flow direction. So I'm going to choose just a flow arrow here. Maybe we'll do filled, make it a little bit bigger. Symbols, we'll leave all those there. And notation. This one's important because this says what do we want to display when we have results. So node IDs, that'll be helpful. Node values, that'll give you the pressure at the node. Link IDs, these are the pipes. And then link values, by default, that's the flow rate. I'm going to also make the font size bigger because it's just tiny when it starts off. Let's make it 15. There we go. All right, labels, we're good there. Link size, let's go ahead and upgrade that a little bit. Nodes, let's make those a little bit bigger too. Great. Press OK. All right, now we've got our black map here. In our lab documents, we are going to create a flow network that simulates this very simple flow network here. It's got two nodes, got three pipes. The pipe A is going to have 3,000 feet, B 2,000, C 4,000, and then different diameters. So I'm going to keep this over here, and we'll have EPANET over here, and then we'll just try to keep track of everything as we go. So how do we start? Well, we're going to start by creating nodes, and we'll click on this circle right here, add a junction. Junction is the same thing as a node. 1 and 2. Beautiful. Doesn't really matter where you put them. The way it's set up right now, the coordinates are just arbitrary. Just to kind of follow, well, I don't need to update the junctions there. All right, now I'm going to create some links, And this is the link tool right here, actually. Add a pipe. Click on that. And then just want to be in the ballpark, kind of over that. And if you click it correctly, it's going to give you that little white box there. Okay. Again, it doesn't matter how long you draw this pipe, and you don't have to get it perfect because you're going to tell EPANET how long it is. All right, so we just connected that. We'll go straight across for pipe letter B, and then we'll do another one down here. Great. I'm going to zoom in just so we can see this region a little bit better. There we go. And then get my cursor, and then let's go ahead and just update some information on these pipes. So I clicked on pipe number 1. That length is supposed to be 3,000. So 3,000. The diameter is 12. We'll keep that. And then the roughness. Okay, let's talk about units here. To do so, I'm going to go over to Help and click on Units. So some things to know about EPANET. It's going to use US units if you choose flow to be CFS, million gallons per day, acre feet per day, etc. So if these are your flow rates, then automatically we're going to be in US units. That's how it works. So what does that mean? Well, EPANET has mixed units. It's going to be a little confusing. Pipe diameters are in inches. Tank diameters are in feet. Elevation is in feet. Um, Pressure is in PSI. Let's see what else. Length is in feet. Friction factor unitless. Roughness is for Darcy Weisbach, millifeet. Okay, no one uses millifeet ever. EPANET does. So just keep that in mind. So we'll go back now to this and roughness. What is our roughness? Well, it's not 100 millifeet. We, for this lab, say that we're dealing with, let's go down a little bit farther. It's a cast iron pipe, and the roughness for cast iron is 0.85 millifeet. So if you look in your table in your textbook, you'll probably see something similar. It might be 0.00085, something like that, right? That's going to be the same as 0.85 millifeet. There we go. That's the only parameters we're going to change there. And it will save automatically, and we'll just X out of there. I did want to update the name of that though, just to match the nomenclature in the lab. So we'll call that pipe A. Great. 3,000 feet, 12-inch diameter, 0.85 millifeet. Okay, let's move on to the next one. We'll call this pipe B. The length is going to be 2,000 feet. The diameter is 8 inches, and the roughness is 0.85 millifeet. Now, if you forget to update the roughness and you end up with a very incredibly low pressure, that is because you left the 100 in there, and the Darcy-Weisbach equation will calculate a really high energy loss. All right, lastly, pipe C. We've got a length of 4,000, a diameter of 16, and then a roughness of 0.85 as well. Great. Now all of our pipes have been parameterized, but we got to put some flow in here. So the way EPANET needs flow is it needs a source. So we're going to add a reservoir. That's going to be our source. Click it over here. And then we'll need to connect that reservoir to the inlet node. So a few things to note with the reservoir. Go ahead and click on that. It's going to want to know the total head. Where is that reservoir? How much elevation or depth of water is in that reservoir? Right now it defaults to 0. EPANET can work with that, but you're going to have negative pressure in the system. So let's give it a positive head so that any flow that moves through the system will still have a positive pressure based on that head of 100, which is feet. Okay, we don't care about energy losses between the reservoir and this node. This is really just a hack to allow an arbitrary input of flow into this network. So we're going to say the length is 1 foot. So you could put 0.1 if you wanted to. We're going to say the diameter is something big, 48 inches. The roughness, whatever, 0.01 millifeet. Okay, this is really just an imaginary pipe. We just want to say flow is coming directly into the system. Great. So we've got flow, but we don't have anywhere for that flow to go. So now we've got to go over to this junction and give it a demand. So we're going to deal with base demand here. The pattern deals with the daily fluctuations. The base demand based on this problem was 12 cubic feet per second. So because we set our flow units to be cubic feet per second, we're just going to write 12 in there. Note that I can adjust the elevation of the node. That's something that you can experiment with to see how that affects the pressure. But right now we'll leave it as 0. All right, so go ahead and save our model. Give it a name. We'll just say lab 2 part 1. I don't expect you to turn this part in for your lab, so you can simply uh, save it, but you don't have to turn it in. This is really just for you to learn how to use EPANET. We also do this for the homework. When we're ready to roll, let's go ahead and click the lightning bolt for run. Run was successful. Yay. All right. So you can see the arrows updated the flow, but we're missing some information. I want a little bit more information here. So let's see if we can get that. I thought we turned that on. All right. For our links, labels, notation, display values. Yeah. Okay. Flow arrows, background. Okay. Okay, so to visualize the results here, we're gonna have to expand our screen here a little bit more and look at this little browser window. So a couple things here is if we are under the data tab, we can double click on any junction and it will pull up the elevation and the demand there. So that's just something that you can look at. So that's your junction table. I think you can actually pull up a full on junction table here by clicking on the table, network nodes, okay, and there it is. There's all the information. So the reservoir had -12, junction 2 had 12. Here's the heads and pressures on those. And then we can also open up the link table. And this is going to show the flow in each pipe. Something you could copy and paste and put into a table. Calculate the friction factor. That's nice. And then the head loss in the pipe. That's great. Also the velocity. But we can also visualize that. So that was the data tab. Now the map tab. I want to look at under nodes. I want to see pressure. Boom. Now we can see the pressure under links. I want to see flow. And there's our flow. That's great. So now we can visualize how the flow is distributed in the system. You can mess around with a scale. This scale, color scale isn't very helpful here, but you can see that now we've got 40 psi at this node, 34 here, and then you can see that it has distributed the flow based on the lengths and diameters of the pipe. Let's take a quick look at the project layout input file that you'll be using to design the water tower. So under the lab 2, I am downloading this input file, .imp file, and then in EPANET, I can go to my downloads. Hopefully you put that in your project folder though, because you want to kind of save everything in the same place. Note that by default, it's looking for .NET files. You're going to have to change that to .imp files to find that file. That just means it's an input file, right? Okay. So here's that input file. And let's just take a look at what we got here. We've got a reservoir. There's no head in that system. That doesn't matter because we're going to have a water tower. There's a pump. It's got a pump curve. We're actually not going to worry about that pump either. But the water tower we do want to look at. So let's open that one up. You can see that the elevation right now is 80. That's 80 feet. So that's going to be the bottom elevation of the tank. The initial level is 10. That's the depth of the water in the tank. You're going to adjust that based on the diameter and the volume in the tank. And then here's the diameter as well. Again, remember, EPANET isn't going to adjust the depth in the tank if you adjust the diameter. I moved it from 80 to 90. The initial level didn't change. So that's the manual calculations that you're going to have to do based on the known volume. The other things to note is that at a particular junction, you are going to input base demand. So for scenario one, that's the maximum daily demand for each junction. For scenario two, maximum hourly demand. Scenario three, average daily demand in the wintertime. When you put the fire demand in the system, you are going to click on a node. That base demand is already going to be in there. You have to just use a calculator and add the fire demand on top of the base demand. Let's go and go under view options. I like my black background. We don't care so much about flow arrows in this case, but let's go ahead and just add all those different values. Okay. Make those links a little bit bigger and then make the font size a little bit bigger so we can read it. Ooh, that was a little big. Let's change that. Let's dial it back to 10. There we go. All right. Um, Maybe this is a little too much information. I'm going to get rid of the link IDs and link values. We're really focusing on the pressures here, so we'll just take those off and we'll focus on the node IDs. Right now we haven't run anything, so that's why you've got an NA value for pressure. So for the lab again, you are going to go into the tank. You're going to change the elevation, the initial level, and the diameter based on the scenarios. And you're going to do some iterations to make sure that the pressures in the system meet the specifications. You'll go into these nodes and you're going to change. You don't need to worry about the links, that's already parameterized, but you're going to change the base demand of the nodes based on the scenarios. All right, that's all. Good luck modeling out there.